Hello everyone, welcome to our presentation. Today we're going to explore fractions and decimals. This is an exciting topic that will help us understand how to work with parts of a whole and numbers that are not whole. Over the next few slides, we'll cover the basics of fractions, how to convert them to decimals, and some useful tips. I'm glad you're here, and I look forward to sharing this learning journey with you. Welcome to the contents of today's presentation. We'll start with an introduction to fractions, which are fundamental to understanding parts of a whole. Next, we'll explore unit fractions, which are fractions with a numerator of 1, like 1/2 or 1/3, and they play a key role in building other fractions. Moving on, we'll look at how to represent fractions visually and symbolically, making it easier to grasp their meaning. We'll then cover different types of fractions, such as proper, improper, and mixed fractions, to see the variety in how fractions can appear. Understanding the difference between like and unlike fractions is important too, especially when performing operations. That leads us to adding and subtracting fractions with like denominators, which is straightforward, and then extending to unlike denominators, which requires finding common denominators. We'll also delve into the concept of equivalent fractions, different fractions that represent the same part of a whole, and how to identify and generate them. Moving forward, we'll compare fractions to see which is larger or smaller, and then we'll transition into decimals, starting with an introduction to what decimals are and how they relate to fractions. The presentation continues with operations involving decimals, such as addition, subtraction, and division, highlighting their similarities and differences with fractions. We will explore the multiplication and division of fractions and decimals, emphasizing the methods to perform these calculations accurately. Additionally, we'll look at converting between metric units, which is essential for practical measurement tasks. Finally, we'll conclude with a recap of key concepts, ensuring a clear understanding of how fractions and decimals are interconnected and how they are used in everyday contexts. Throughout this journey, our goal is to build a solid foundation for understanding and working with these mathematical tools. Let's start with the basics. A fraction. A fraction represents a part of a whole. Imagine you have a pizza and you cut it into equal slices. Each slice is a fraction of the entire pizza. The key idea here is that a fraction shows us how much of something we have compared to the whole. This concept is fundamental because it helps us understand parts of a whole in everyday life, like sharing or dividing things equally. Throughout this presentation, we'll explore how fractions work and why they are so important in math and real-world situations. Today, I want to talk about representing fractions. When we talk about representing a fraction, we're essentially finding ways to show parts of a whole. This helps us understand what the fraction actually means in real life. For example, if we have a pizza divided into equal slices, each slice can represent a fraction of the whole pizza. Visuals like pie charts, number lines, or even shaded regions are great tools to help us see these parts clearly. It's important to grasp that the way we represent fractions can vary depending on the context, but the core idea is always about showing how much of a whole we're talking about. This understanding is fundamental because it lays the foundation for more complex math concepts involving fractions later on. So, in essence, representing fractions visually and practically helps us connect numbers to real-world situations. Now, let's take a closer look at the different types of fractions. On this slide, you'll see two examples. The first example is 12/7, which is written as 12/7. This is what we call an improper fraction because the numerator, 12, is larger than the denominator, 7. Improper fractions can be useful in certain calculations and are often converted to mixed numbers for easier understanding. The second example is 7/2, written as 7/2. This is another improper fraction, with the numerator greater than the denominator. Recognizing these types of fractions helps us understand their value and how they relate to whole numbers. Throughout this presentation, we're exploring the different forms fractions can take, and understanding their types is key to mastering how to work with them effectively. Whether proper or improper, each has its role in math problems and real-world applications. Now, let's talk about like and unlike fractions. These are two important categories of fractions that help us understand how fractions relate to each other. Like fractions have the same denominator, which means they share the same bottom number. For example, 1, 4, and 3, 4 are like fractions because they both have 4 as the denominator. This makes comparing and adding them pretty straightforward. On the other hand, unlike fractions have different denominators, like 1, 3, and 2, 5. Working with these requires a bit more effort because we need to find a common denominator before we can compare or add them. Understanding the difference between like and unlike fractions is key because it guides us on how to simplify, compare, or combine fractions effectively. It's a fundamental step in mastering fraction concepts, and it ties into the overall theme of understanding how parts of a whole relate to each other. Let's take a closer look at unit fractions. These are fractions where the numerator is 1, like 1/2, 1/3, or 1/4. They are called unit because the numerator is always 1, which makes them fundamental building blocks in understanding fractions. Unit fractions help us break down whole objects into equal parts, making it easier to understand division and sharing. For example, if you divide a pizza into 4 equal slices, each slice is 1/4 of the pizza, a perfect illustration of a unit fraction. Understanding unit fractions is crucial because they connect to the larger concept of fractions as parts of a whole. They also set the foundation for learning about other types of fractions and their relationships. So, in our overall theme of understanding parts and wholes, unit fractions are the starting point that helps us see how to divide and share things fairly. Now, let's move on to the concept of equivalent fractions. When we talk about equivalent fractions, we're referring to fractions that represent the same part of a whole, even if they look different. For example, 1, 2, and 2, 4 are equivalent because they both cover the same portion of a whole. The key idea here is that multiplying or dividing both the numerator and the denominator by the same number doesn't change the value of the fraction. Recognizing equivalent fractions is important because it helps us compare, simplify, and understand fractions better. This concept ties into the larger theme of understanding how fractions work and how to manipulate them to solve problems more easily. Remember, different fractions can look different but still be equal in value. That's the power of equivalent fractions. Let's talk about adding and subtracting like fractions. When we say like fractions, we mean fractions that have the same denominator. This makes our calculations much simpler. First, for addition, you just add the numerators together while keeping the denominator the same. For example, if you have 3/8 plus 2/8, you add the 3 and 2 to get 5, and the denominator stays 8, so the answer is 5/8. Similarly, for subtraction, you subtract the numerators and keep the denominator the same. So, if you have 7/10 minus 3/10, you subtract 3 from 7 to get 4, and the denominator remains 10, making the answer 4/10. The key point here is that when the fractions are like, the process is straightforward. Just add or subtract the numerators. This connects to our overall theme of understanding how to work with fractions efficiently. Recognizing when fractions are like is the first step to simplifying these operations. Now, let's move on to addition and subtraction of unlike fractions. When we talk about addition, the first thing to remember is that the fractions need to have different denominators. To add these fractions, we need to find a common denominator. This usually means finding the least common denominator, which is the smallest number both denominators can divide into evenly. Once we have that, we convert each fraction to an equivalent fraction with the common denominator, and then we simply add the numerators together. The same idea applies to subtraction. We find the common denominator, convert the fractions, and then subtract the numerators. It's important to keep the denominators the same so we can directly compare the numerators. Overall, the key is understanding that for unlike fractions, the process involves a few extra steps, finding that common denominator first, before we can add or subtract the numerators. This concept connects back to the overall theme of working with fractions and understanding how to manipulate them effectively, no matter if they look different at first glance. Now, let's talk about subtraction of mixed fractions. When we subtract mixed fractions, the key is to first look at the whole numbers and the fractions separately. If the fractional part of the number you're subtracting is larger than the fractional part of the number you're subtracting from, you'll need to borrow from the whole number. This means you'll take one from the whole number, turning it into a fraction that can be added to the fractional part. Remember, this step makes the fractional part larger, so subtraction becomes easier. It's important to write the mixed fractions as improper fractions when subtracting. This often simplifies the process, especially when dealing with borrowing. Once you've done the subtraction of the improper fractions, don't forget to simplify the result if possible. Overall, the main points are to handle borrowing carefully, convert to improper fractions for easier calculation, and then simplify your answer. These steps help keep the process clear and accurate, and they connect to our overall goal of mastering operations with fractions efficiently. Now, let's move on to the next key concepts in working with fractions: multiplication and division. When we talk about multiplication of fractions, the main idea is pretty straightforward. You multiply the numerators together to get the new numerator, and the denominators together to get the new denominator. It's like multiplying fractions step by step. For division, it's a bit different. Instead of dividing, we actually multiply by the reciprocal of the second fraction. So, if you're dividing one fraction by another, you flip the second fraction upside down and then multiply. This approach makes the process much simpler and keeps everything consistent. Both of these operations are crucial because they help us solve more complex problems involving fractions, especially when we're working with real-world situations like cooking or measuring. Remember, the key points are to keep the numerators and denominators clear, and to understand that dividing by a fraction is the same as multiplying by its reciprocal. Connecting this to the overall theme, mastering these operations gives us more flexibility and confidence when working with fractions, which is essential for advancing in math. All right, let's dive deeper into the multiplication and division of fractions. When we talk about multiplication, the key idea is that we multiply the numerators together and the denominators together. It's a straightforward process, but what's important to remember is that multiplying fractions often makes the fraction larger or smaller depending on the values, so always simplify if possible. Now, for division, it's a bit different. Dividing fractions involves multiplying by the reciprocal of the second fraction. So, instead of dividing directly, we flip the second fraction and then multiply. This approach makes the process much easier and consistent with how we handle multiplication. Both of these operations, multiplication and division, are essential because they help us work with parts of a whole, ratios, and rates, which are common in real-world problems. Understanding these concepts thoroughly is crucial because they connect to many other math topics and real-life situations. So, keep in mind, multiplying and dividing fractions are powerful tools for solving a wide range of problems. Now, let's talk about decimals or decimal numbers. A decimal number is essentially a number where the whole part and the fractional part are separated by a decimal point. This decimal point is quite important because it helps us distinguish between the whole number and the part less than 1. The digits that come after the decimal point represent a value smaller than 1, giving us a precise way to express fractions in a more manageable form. For example, if we look at 3.14, the 3 is the whole part, and the 0.14 is the fractional part, indicating a value slightly more than 3. Understanding this concept is fundamental because it allows us to work with more exact numbers, especially in measurements, money, and various calculations. So, the decimal point acts as a separator, and the digits after it tell us how much less than the next whole number we're dealing with. When comparing decimals, the first thing to look at is the integer part. The number with the larger integer is the greater number. If both numbers have the same integer, then we move to the next place value, which is the tenths. Check the digit in the tenths place. The one with the greater digit here is the larger decimal. And if those are the same, continue comparing the hundredths, thousandths, and so on until you find a difference. For example, if you're comparing 3.45 and 3.47, start by looking at the integers. Both are 3, so they're equal. Then check the tenths. Both are 4, so they're still equal. Next, look at the hundredths, 5 versus 7. Since 7 is larger, 3.47 is the greater number. Remember, this step-by-step comparison helps us accurately determine which decimal is larger. Now, let's look at how we perform operations with decimals, focusing on addition and subtraction. When adding decimals, it's important to align the decimal points to make sure we're adding the correct digits together. For example, if we add 22.3 and 34.1, we line up the decimal points and add as we would with whole numbers, remembering to keep the decimal in the right place. Similarly, for 1.234 plus 4.1, we can think of 4.1 as 4.1 to align the decimal places properly before adding. Moving on to subtraction, the same rule applies regarding decimal alignment. For instance, subtracting 34.1 from 76.3 requires lining up the decimal points and subtracting as usual. And for 4.32, 1 minus 4.1, again, we can think of 4.1 as 4.1 to keep everything aligned. The key takeaway here is that when working with decimals, always pay attention to the decimal points and ensure they are aligned before performing your operations. This helps maintain accuracy and clarity, which is essential as we expand our understanding of decimal calculations within broader math concepts. Now, let's move on to some multiplication with decimal numbers. First, we have 5.67 multiplied by 1.2. To solve this, I like to think of it as multiplying 567 by 12 and then adjusting for the decimals. It's a good way to keep the math straightforward and avoid confusion. Next, we have 39.8 multiplied by 12. This one is a bit simpler because 12 is a whole number, so we just focus on multiplying 39.8 by 12 directly. Remember, the key here is to carefully line up the numbers and keep track of where the decimal points go in the final answer. The main takeaway is that when multiplying decimal numbers, it often helps to temporarily ignore the decimals, do the multiplication as if they were whole numbers, and then place the decimal point correctly in the product. This approach makes the process more manageable and less error-prone. These examples show how understanding decimal multiplication is essential for working accurately with real-world measurements and calculations, which ties back into our overall theme of mastering decimal operations for practical use. Now, let's take a look at decimal division with an example, 68.5 divided by 5. When we encounter a division problem like this, the key is to understand how to handle the decimal point. One helpful approach is to think about eliminating the decimal from the dividend or divisor, which often makes the calculation simpler. In this case, since the divisor is a whole number, 5, we can proceed directly. We ask ourselves, how many times does 5 go into 68.5? To make this easier, we can think of 68.5 as 685 tenths. Alternatively, we could multiply both the dividend and divisor by 10 to shift the decimal point to the right. That transforms our problem into dividing 685 by 50, which makes the process more straightforward. The key takeaway here is that understanding how to manipulate decimals during division helps us simplify the problem, ensuring accuracy and efficiency. Remember, always look for ways to convert decimals into whole numbers when possible. This technique is a powerful tool in decimal division and helps us connect back to the overall theme of mastering number operations with decimals. Now, let's move on to slide 19, which focuses on the conversion of metric units. This is a crucial part of understanding how to work with measurements in the metric system. Essentially, converting metric units involves using powers of 10, which makes the process straightforward and systematic. When we shift from one unit to another, such as from meters to centimeters or grams to kilograms, we're either multiplying or dividing by 10, 100, 1,000, and so on. The key point here is that these conversions are simplified because of the decimal system. For example, moving from kilometers to meters is multiplying by 1,000, while going from grams to kilograms is dividing by 1,000. Recognizing these relationships helps us make quick, accurate conversions without confusion. This concept ties into the overall theme of the presentation, understanding and mastering measurement units to ensure precision and clarity in our work or studies. By grasping these conversions, we can communicate measurements effectively across different contexts and applications. Thank you all for your attention today. I want to take a moment to emphasize that the key takeaway from this presentation is the importance of staying informed and proactive in our efforts. Remember, the actions we take now can make a significant difference. As we conclude, I want to express my sincere gratitude for your time and engagement. Please, stay safe and stay home whenever possible. Your health and well-being are the top priorities, and together, we can work towards a safer, healthier community. Thank you again, and take care.